In the second part of lesson 10-2A, we're going to be taking a look at simplifying and multiplying radicals that have variables in them. So just a quick warm up. When you have, like for instance, the square root of 64, we know that the square root of 64 is equal to 8 because 8 times 8 equals 64. Or I could say 8 squared equals 64. So taking the square root and squaring a number are opposites. So when you come over here and take a look at the square root of x squared, you think, okay, what number times itself gives you x squared? And that would just be x, or x to the first power, because x times x equals x squared. So when I ask for the square root of x to the fourth power, what two factors multiply together to give you x to the fourth power? And that would be x squared times x squared. And then when we have x to the sixth power, it would be x to the third power. That would be the square root. So any time that you have a variable that has an even number as the exponent, you're just dividing it by 2. You're just cutting it in half. So if I were to give you, let's say, like x to the fifth power and ask you to take the square root of it, you're going to want to subtract 1 and break this up into two factors, x to the fourth times x to the first power. Because x to the fourth is a perfect square, it would be x squared. And then, of course, this part would have to stay under the radical, just the x, and then that would simplify to this. So it would go from here to here. So if you have an odd number, just subtract 1 so that you have a perfect square, and that would be how you'd find the factors. Okay, so let's take a look at a couple examples where we're going to be finding or using a radical that has a variable, has variables in it. We're going to be simplifying, okay? And then we'll take a look at one where we're multiplying. So for this first one, we've got the square root of 64 times x to the fourth. Well, if we were to break this up, it's pretty easy because the square root of 64 is a perfect square. And the square root of x to the fourth is also a perfect square because it's an even exponent. So square root of 64 is just 8. And the square root of x to the fourth is just x to the second power. And so this would be simplified just like that. So that one's pretty easy because everything is a perfect square. Let's take a look at where it's not. Whoops. So in number 5, we've got the square root of 48 times x to the third power. So here we're going to want to factor out two numbers that multiply together to give you 48. And one of them we want to be a perfect square. So go over to all of the highlighted numbers that you see on the chart here and just use your calculator. So let's go with, like, if it's 48, we want to take everything that's less than 48 and see, is it divisible by 36, 25, 16, 9? Try any of these factors to see, could you divide 48 by any of those? And yes, you can actually. 16. So I could break this up into 16. 48 divided by 16 is 3. So square root of 16 times 3. And then, being that this is an odd number, I want to subtract 1, and I'll have x squared and then just x. So let's just pull apart these factors. I've got the square root of 16 times the square root of 3 times the square root of x squared times the square root of x. So I just pulled them all out from underneath the radical. Well, the square root of 16 is a perfect square. It's 4. Also, the square root of x squared is a perfect square. It's x. Now, these two, square root of 3 and square root of x, those two are not perfect squares. I can't simplify, I can't factor them out anymore, so I'm just going to keep them underneath the radical, 3x. So the simplest form for the square root of 48x to the third power would be 4x radical 3x. All right, let's try another one. Okay, here we've got 40 times x to the 10th times y to the 5th times z. All right, so let's factor out first. Let's do 40. And so we want to look at numbers that are less than 40, and they're really the same numbers here, 36, 25, 16, 9. Can we take 40 and divide it by, what's the biggest one of those factors we can divide by? And that would be 4, right? So we've got 4 times 10 gives us 40. And then we've got the variables. Well, being that the x has a positive exponent, it's a perfect square. So I'm just going to leave that x to the 10th. Now with y, it's an odd number. So I'm going to subtract 1, and I'm going to factor that y to the 4th times y. And that would be y to the first. And then I have the z to the first. Okay, so then let's pull all of these apart. We've got square root of 4, square root of 10, square root of x to the 10th, square root of y to the 4th, square root of y, and square root of z. Okay, they're all being multiplied together. Now, what's a perfect square? Well, this one is, that would be 2. And then x to the 10th, that would be x to the 5th. And y to the 4th is a perfect square. That would be y to the 2nd. And then anything else left under the radical, like this is under the radical, that's not a perfect square, that's not a perfect square, that's not a perfect square. All of those, we're going to push them back under the radical, multiply them together. 10, y, z. Those all are going to stay back under the radical because they are simplified. That's as simple as you can get. So then our final simplified answer would be 2x to the 5th y squared times radical 10yz. Wow, crazy looking. It's awesome. Okay, let's try one where we are finding the product with variables, okay? So on this one, I'm going to want to push everything back together under the radical so I can pull it out the way that I want to. Let's first look at the numbers that are outside the radical, so the coefficient. -2 times 5. I can pull those two together, and that would be -10. Now what I'm going to do is push everything that's under the radical, this part and this part, I'm going to push it all back under the radical. I'm going to multiply those two together and push them back. So if I do that, if I push them back under the radical, I'm going to get 192. 32 times 6 is 192. And then I'm going to get x to the, if I add the exponents, I'd have x to the 7th. So I'm going to keep it x to the 6th and then just x to the 1st because I know that x to the 6th is a perfect square. So let's just keep that. Okay, so out in front we have a coefficient of -10. Now let's factor 192 the way that we want to. So look at all the numbers less than 192. So we're going to look at all of these in yellow. What is the greatest perfect square that it's divisible by? So take your calculator, say, what can I divide 192 by? And you're going to find that it's 64. So if I take 64, or 192 divided by 64, it will be 3. 64 times 3. Then I'm going to keep it x to the 6th times x. And if you want to pull them all apart, you can. So square root of 64, square root of 3, square root of x to the 6th, square root of x. Now I've got the -10 out in front. It's being multiplied as my coefficient. We're going to multiply it by 8 because the square root of 64 is 8. What else is a perfect square? Right here, x to the 6th. That's x to the 3rd. That's a perfect square. So that's everything. That's going to be our coefficient out in front of the radical. What's going to stay under the radical? Well, this and this, because they can't be factored. 3 times x is 3x. Still not quite done because take a look at the coefficient. It still can be simplified. So let's move over. -10 times 8 would be -80. And then I have x to the 3rd. That's my coefficient. And then under the radical, the root is 3x. And that would be my simplest form. So what I did was I took the multiplication, I pushed everything back under the radical, here and here, and then I pulled it out the way that I wanted to into factors that are perfect squares. Hopefully this video was helpful. Thank you for joining me. Have a great day.